Hi everybody. Here's another chance for us to practice finding angles in and around circles. You want to get ahead of me, that's for sure. And the first thing I'm sure that you always want to do when you're solving a puzzle like this one is get all the arcs that you can. Get all the arcs. You have to figure out all the arcs ahead of time. I'm thinking that's true. In class, I know I'll turn it off and look at everybody funny until they get all the arcs figured out. So you guys at home do the same thing. FE is 48. And AF is 36. And I do have a couple of parallel lines, it says here. AB is parallel to FC, and it's marked that way. Now I got to remember, there's something to do with these parallel lines going to tell me about some arcs. And I have a diameter EC. And whenever you get a diameter, it's important that you recognize you're going to get a semicircle. And that semicircle is going to give you 180 degrees. So we ought to be able to figure out about AB and BC. Because parallel lines cut congruent arcs. This arc would have also been 36 degrees. That is arc BC. I'm told that EC is a diameter. Therefore, I'm certain I'm going to get 180 degrees from arc EAC. Looking at what is available to me, I got 72 and 48. 72 and 48. Alexa, what's 72 and 48? 120, I guess?
72 plus 48 is 120.
There we go, with 120 there. That's going to leave 60 right here, huh? So now I know a little about that. And as I go venturing over to figure out about these other arcs, it's nice to recognize that these central angles are going to be congruent. Those are vertical angles. This one must be 36 degrees. Therefore, angle 1 is 36 degrees. Therefore, arc ED is 36 degrees. That's going to be important to me as well. AF was 36, and ED is 36. Isn't that interesting? But what about arc DC? Yeah, I expect those to add up to 180. I got a semicircle here. Take that 36 out of that 180, and for DC, we expect it to be 144. And arc BC, we already figured out to be 36. And arc AB, it had to be 60. So what were the tricks you have to remember? Well, parallel lines cut congruent arcs. That happens. Vertical angles give you, if central angles are vertical, then you're going to get opposing arcs that are congruent. And always look for a diameter giving you a semicircle, and get those angles, those arcs to add up to 180. Now we're just going to figure out some angles, which will be fun and easy. Angle 1's a central angle. And how do we measure those? Same as the arc it cuts. Angle 2, well, that's an inscribed angle. That'll be 1/2 of the arc it cuts. What arc does it cut? It cuts arc ED, so it's a half of 36. That'd have to be 18 degrees. Angle 3, that'll be another 18 degrees, shouldn't it? I'm thinking a couple of reasons. This is an isosceles triangle. I know that this radius is congruent to that one. And I also know that this angle cuts the same size arc. And an inscribed angle is 1/2 the arc it cuts, so therefore angle 3 is also 18 degrees. How about angle 4? Angle 4 is an inscribed angle. And it cuts an arc from A to D, which is 72 and 48. And I think we added those up to 120 a minute ago. 72 and 48, so there's 120. Therefore, angle 4 must be 60 degrees. 1/2 of the arc it cuts. And I was supposing that this arc would have been 120 degrees. Angle 5. Angle 5 is not a central angle, not an inscribed angle. I'll have to average the arcs that it cuts. I'll look at the vertical angle partner. It cuts an arc of 36 degrees. I'll follow angle 5 out and see it cuts also arc FD, which is 36 and 48. That must be 94 degrees. Hold on a second, let me get that right. 84 degrees, I apologize. That's 84 degrees. I'll add those up and divide by 2. Looks like 120 divided by 2, therefore 60 degrees. I'm declaring angle 5 to be 60 degrees. Now that I'm thinking about it, I should have recognized that to be true, shouldn't I? For lots of other reasons. I'd stop the video and talk about it in class, but right now, let me tell you, yeah, these are corresponding angles, aren't they? When these lines are parallel, those corresponding angles had to be congruent. So I'm happy that angle 4 and angle 4 was 60 both times. Angle 4 and angle 5 matched up. And then what about angle 6? Where do we find angle 6? Well, an angle outside the circle formed by a couple of secants. We'll get the big arc that it cuts, follow angle 6 out. Cuts this arc, AD, which was 120 degrees. What other arc does angle 6 cut? It cuts this small arc BC, excuse me. So it'll be 120 minus that 36 divided by 2. And that's going to be 74. How about 84? Take that back. 84 degrees divided by 2, so that'll have to be 42 degrees for angle 6. So practice these and do yours well. And I'm going to give you a quiz this week with questions like this. You'll have a page like this to do.